Hi, everybody. This video is to get us prepared to look at section 5.2, which is all about factoring quadratics. So in order to talk about factoring quadratic expressions, we need to know what is a quadratic expression and why do we want to factor them. The answer to what is a quadratic expression, it's a polynomial where the largest power is a 2. Quadratic comes from the same root as squared, and so the x squared is the largest power. And then you might have some other x terms, like this quadratic expression has an x, and then terms without any x's, this one has a -6. So this x squared plus x minus 6 is a quadratic expression. The question, why do we want to factor them, is what we're going to be exploring in this video. Now, before I graph a quadratic expression, let me just graph a basic function like linear function, like y equals 3x minus 5. And linear functions create lines as the graphs. The quadratic expressions do not create lines when you graph them. So to see what shape we get, let's use a table. And I'm just going to start with the easiest x, which is 0, and I'm going to put in x equals 0, and my corresponding y output is at -6. And I'll just put in a couple more numbers and see what we get. Okay, when I put 1 in, I get -4, 2, I get 0, 3, I have to zoom out a little bit. Yeah, notice, like, if I were to connect these with the line, then I would have to keep going this direction. So it's hard to tell, but it's making me doubt that this expression is going to give me a line. Let me try some negative numbers. How about -1 for x? Oh, well, that's interesting. Yeah, definitely not a straight line anymore. Let's try -2 for x. Huh, it's coming back up. And -3 for x. Oops, there. And finally, negative for x. And what you can see is my function seems to kind of be, as x increases, it comes down towards a low point and then actually turns around and goes back up. So quadratic expressions do not create lines when you graph them. They actually create what are called parabolas. The graph of a quadratic function or quadratic expression is called a parabola. It looks like a U, kind of like a stretched out U. So this is what a quadratic function looks like as a graph. Why would we want to factor them? Well, the reason we would want to factor a quadratic expression is, like with most functions or most graphs, there are important and interesting points. For example, if I look at my earlier one, my straight line, y equals 3x minus 5, there are two interesting points. There's the y-intercept, which I can just read from the formula, and there's also the x-intercept, where my function touches or crosses the x-axis. And these interesting points are, well, they're valuable pieces of information about this linear equation. I can ask the same sorts of questions about a quadratic function. I can say, what is the y-intercept? Where does it touch or cross the y-axis? And this one crosses when x equals 0, y equals -6. And it's no coincidence that the -6 on the point in the graph is the same as the -6 that is the constant term. And just like with the linear function, I can also ask, well, what are the x-intercepts? Where does my function touch or cross the x-axis. It crosses when x equals -3 and when x equals 2. And this is the key. The reason to factor a quadratic expression is to identify the x-intercepts of the graph. In my next video, I'm going to show you how you factor that quadratic expression by hand. But what I want you to remember is the whole reason we're doing it is so we can identify the places on the function where the output is 0. We are identifying the x-intercepts. And in fact, I can write this whole function using the x-intercepts. I have an x-intercept of -3 and an x-intercept of 2. Now, if I put in x plus 3, x plus 3 and x minus 2, sorry, let me start that over. I have an x-intercept at -3 and +2. So you might think I'd do x minus 3 and x plus 2. But unfortunately, that doesn't quite match. And what you're going to need to remember, and I'll come back to this a lot, is the x-intercepts, you change the sign from positives to negatives. When the x-intercept is at x equals -3, the term, this is called the factor, is x plus 3. Plus 3 versus -3. And then the x minus 2 is the opposite of the x-intercept, which is +2. There's one other point on this function that's pretty interesting, and that's where it turns around. That's called the vertex, and we come back to that, I believe, in a later class. But what I want you to remember is, what is a quadratic expression? It's a polynomial where the largest power is the 2. Why do we want to factor them? So we can identify the x-intercepts on the graph, which is called a parabola. All right, thanks for watching. Next video, we'll show you how to factor by hand.